Hey folks, welcome to another episode of ML for Noobs. Now, I was thinking the last episode we did around which Rhine is it. I thought that was it, right? We've got it working, we've got this upload interface, looks pretty slick, and we can automatically categorize an image as either Ryan Reynolds or Ryan Gosling. However, we encountered a few problems. And specifically, the issue is that it would often categorize Ryan Gosling, it would incorrectly categorize him as Reynolds. So I have a few examples here. This one, I have no idea. Okay, so he's wearing a cap. This one should have been obvious, right? This is Ryan Gosling. And when we ran this, we saw that it would categorize him as Reynolds, and there was something wrong there. And so what I want to do in this video is figure out exactly what is going on and how we can address that. And so that's the whole purpose of this video, is what we're going to be doing. Let's get right to it. Now, just sort of out the gate, we don't know a whole lot about deep learning and all of this stuff yet, but I sort of have some assumptions about what might be going wrong. Now, one is, I think the size might actually be too small. And so when we collect all of these images, we're specifying a size parameter of 224. This is 224 pixels. So we're fitting the image into 224 by 224 pixels. And so this might actually be too small. And it might mean that, you know, the images are just not well suited for this dimension. Maybe if we make the images bigger, you know, maybe at such a small size, it can't tell the difference between the two, but at a larger size, it would have more detail and be able to tell more. Also, it could be that, you know, I don't know, like it had trouble with some of these black and white images. Maybe the distribution of images is not consistent. And so when it sees a black and white image, it automatically assumes that, oh, this must be Ryan Reynolds, right? Or whatever. It can't be someone else. I don't know. That could be the case. It might not be. But you know, you could see, you know, cases where you had an image like this. It would categorize him as Reynolds, even though it was Gosling. And maybe it's because it's black and white. I don't know. We need to check the distribution for images. I think there might be unclean data in there. So we want to do also a proper check. And so I want to make sure that we've reviewed every single image and make sure that all of the images are okay. And if not, then we need to clean them up. And also, you know, we haven't tried ResNet 50, right? So maybe that'll get us better results. Maybe not. I don't know. All this to say, you know, there's a lot of things that can go wrong, and we need to figure out what it is specifically that is wrong in our case and how we can address that. And ideally, how we can detect it for, you know, future things that we work on, more complicated and complex projects. Cool. All right, there's also one more thing. The images that we're feeding it are huge, right? So these big images, I don't know if they're, you know, maybe we need to do some pre-processing since we've done all of our training on 224 sized images. Maybe we need to resize the input images. Maybe, you know, and that's actually a really simple thing to do. So I think that's a good place to start. Like let's start by doing that, and then as things progress, you know, we'll take a look at some of the more complicated or complex ways of doing this. So what I'll do initially is I will just go to, so I'll shut down my server. We don't need that. I'm going to go to downloads, and here we have our images. I'm going to take a look at, say, G4 incorrect. All right, so G4 incorrect. That's the one that got screwed up here, right? All right, so G4 incorrect. What I'm going to do here is I'm going to resize G4 incorrect, and I'm going to use, so you can use image magic resize image. This is a command line thing. There's a quick way to just really change the size of an image quickly, and so that's what I'm going to do here. So the command is pretty simple. You just do convert and the name of the image. I'm going to take G4 incorrect, and I'm going to pass resize, and we're going to put the size that we need. So I'm going to make it 224 by 224, and then we'll call it G4. So R G4, and we don't know what the result is going to be, so I'm just going to leave it at that. All right, so RG4, that's right here. Let's take a look at what RG4 looks like. All right, looks pretty good. It's just a smaller size, the same image. The aspect ratio hasn't been changed, but the maximum dimension of any individual size is 224 now. So let's run that again. Let's run, so let's head to, all right, projects, fast AI, Ryan's. Let's head here and fire up our server again. And let's take a look. Let's try out this G4 image and see if it's going to work as we expect. So choose our image. Let's pick our G4. That's our new image. And tell me who it is. Okay. All right, that's interesting. It says Gosling now. It says Gosling, see? Gosling 68. Wow. Wow. Okay. That's an interesting result, to say the least. Huh. Resizing the image makes such a huge difference? Okay, all right, you know what? I'm intrigued. What I'm gonna do now is let's take a look at some of the other images that we got wrong. So RG4 was surprisingly correct. So RG4, we're gonna make that RG4 correct. I'm surprised. Actually, if it's correct, we just leave it as it is. We don't flag it, right? And so let me do G3. So remember, G3 was this image, black and white, you know, wearing a hat. I was like, all right, this is a tricky one, right? We don't know if we can get this right or not, but let's give it a shot. So now what I'm going to do is I'm going to do the same thing. I'm going to resize this image, G3 incorrect, and we're going to resize that to 224 by 224 max, and we're going to save that as our g3.jpg. All right, let's try that one. Let's go ahead and try another image. Now we're going to try RG3. What are you thinking? Before I hit that button, what are you thinking? Are you thinking it's going to get it right? Are you thinking it's going to get it wrong? This should be Gosling. Let's take a look. Reynolds. Okay, it screwed this one up as well. So 79% Reynolds and only 20% Gosling, which is what it should have said. So 79%. Let's compare that to G3 incorrect, the original image. I just want to see. 90C. Okay, so there is a difference. There, it's less confident that it's Reynolds now, but it still predicts that it's Reynolds, and so there's a problem there. Why is that still incorrect? That's a good question. G6. I have no idea what's going on here. Like, this is so obviously a picture of Gosling, but why is it thinking that this is Reynolds? So G6 was so incorrect. This is what ended it for me, you know? I was like, okay, there is something seriously wrong that we need to look into. So 94.7%, that's pretty horrible. So let's resize that and take a look at what that looks like. So I'm going to do convert G6. This was G6, right? Yeah, G6, incorrect. We're going to resize that to 224 by 224, and then we're going to say our G6. All right, now let's try our G6. Where's our G6? There it is. All right, tell me who it is. Okay, it's still messed up. It's still saying it's Reynolds. It's still saying it's Reynolds. There's a problem. There's definitely a problem here. And so okay, let's dig into this a little bit more. So we can see that, all right, with the resize of the image, we got better results. We're getting better results, but it's not panacea. It's not solving all of our problems. We still need to dig a little bit deeper to figure out what is going on. All right, so that's one. What's the next one? Well, like, what's a simple thing that we could do just to sort of test this out and see if it's working or not? What's a simple thing? Let's see. All right. You know what? I'm thinking a good place to start is just take a look at the data. You know, right now, I haven't seen a lot of this data. I don't know what it looks like. And so let's take a look at the data. Let's see what that looks like, and maybe there are issues that we can address in the data itself. So let's start there. Let's go. This, we're gonna process that as well, and then we're gonna read the Ryan's directory. Show some. All right. I'm going to be using this. We're going to be using the data bunch down here, right? So let's use that. And then here we want to see sample, so show batch rows equal 3. That's how we do it. All right. So here we're going to insert cell below. Let's get data bunch dot show batch rows equals 3. You can also do fig size equals what was it? 7 by 7. I think that's what it was. Yeah, fig size is 7 by 7. All right, so let's take a look at what that looks like. So I just want to take a look at the data and see what's going on, right? That's what I want. That's what I want to know. What is going on here? And remember, this is the cleanup data, so it's not labeled, so it hasn't been split between data validation and training. Just looking at all the data here. So, okay. All right, this data looks okay. There's some warping going on here. Looks all right. I mean, for the most part, it looks okay. Let's see. Let's put more. Let's put calls equals 10 or 7. Let's have 7 columns and see more images. I'm trying to figure out what is going on here. Wait, that's not working. Rows equal 3, calls equals 7. Calls doesn't work. What is this crap? Calls, okay, this image is cut up. That's surprising. Yeah, honestly, I have no idea what's going on. What I'm going to do is I'm going to do this all over again. Okay, I'm going to go from the start. I'm actually going to exclude the images that I find suspicious. So the ones that I find problematic, I'm just going to exclude. And so just in terms of what we could do to make our lives easier, right? I'm going to take, I'm going to do, let's see. Okay, I'm going to change the size. Now, this is a simple change that we can do just to see if it's going to work better or not. So I'm going to change the size. I'm going to make it 640. 640 seems like a pretty good size. And I'm going to rerun this learner, try it out on a new batch of images, and see if we get better results. Maybe it's a size issue. I don't know. And so, yeah, learn clean. We're not going to load any of the data, of course. We're just going to train it again. What's the point in loading if you're just going to do fit one cycle? Unless you've unfrozen it first. Beats me. All right, so let's get rid of that. And here we are going to do fit one cycle 4. All right, this is going to take a bit longer because these images are now bigger. They're 3 times bigger, which means the area is 9 times larger. And so, yeah, it's going to take a while. What do we got? We got not enough memory. Is that the issue? Okay, it ran out of memory. So what that means is we need to reduce our batch size, right? Where do we set the batch size? I think you do it here. Or maybe you do it in the data bunch. Yeah, I think you do it in the data bunch. Fast AI docs batch size. Let's see. Huh, wait, okay. Image data bunch from CSV, you specify the size. Or in the data block, since we're using the data block API. Together in the data bunch, batch size. So in the data bunch, that's where you're gonna set your batch size. So, okay, so if I wanted to know exactly what that looks like, I'll just do image list dot data bunch, and it says to throw clear error message. Okay, that's not very useful. Let's do doc data bunch. Okay, so data bunch, you can pass a, what do you set the batch size, man? BS. Okay, it's BS. Okay, so BS equals, and here we're gonna use a smaller batch size. So let's put a batch size of, I don't know, 10. I don't have any sense for what those numbers might look like. So yeah, I don't know. I think 10 should be okay, but if it's not, we'll reduce it even more and try again. All right, let's see. Now I got the error again. So let's reduce the batch size to what, 5? Interrupted again. What? I ran out of memory again. With batch size BS. Okay. Created data bunch. Let's take a look at what batch sizes we've encountered before, and yeah, see if maybe we need to reduce it even more. I don't know. Like, so I assume the smallest batch size would be 1, right? Can't go much lower than 1. So run that, and then run this. Interrupted again, yeah. CUDA ran out of memory. That's weird. Okay, so image list dot data bunch. So you call data bunch on the image list. And you have create. In create, you specify your batch size is BS. What is val underscore BS? Let's see. Alright, so we have an item list. Now we have an image list. Okay. Alright. Okay, so this is exactly what we're doing, and he's setting .data bunch BS equals 16, so it's kind of similar to what we're doing over here, except the number is obviously different. I don't think, what I don't understand is why we're having this issue with the numbers. It keeps failing and it says, oh, we're having a problem, but I don't understand why. I don't understand why that's happening. So Okay. All right, so maybe the image is just too big, and even at the smallest batch size, it's too much. I'm gonna try it with 224, but this time with a batch size of 16. What is the default batch size? I don't know. That'd be a good question to ask. What is this? CUDA ran out of memory. Okay, I think maybe it's related to the machine itself and not any of the parameters that I'm providing here, because it just keeps saying it ran out of memory even though I didn't change anything. And so I'm just rewriting the same stuff. It looks like there's some sort of memory leak or something. I have no idea. So I'm gonna do, all right, what am I gonna do? Do I have to restart the machine, or I don't know if I'm gonna have to restart the machine, or if I can just get away with closing the notebook and opening it again. So how do you stop that? Shut down. Okay. Shut down that book and open it again. Let's see if that helps. That is so weird. Like batch size. You can specify your batch size. It's often 16 apparently. Use the batch size we use to collate the data into a mini batch. There's a lot about this whole data thing that I don't understand, and I think I might need to spend a bit of time just sort of studying that to make sure I get the gist. Right, run that, and then head back to, where were we? All right, not doing cleanup. Okay, we're not going to look at the cleanup data. What we want to see is from top losses, blah blah. All right, so here, split none. So we're still doing cleanup. Is that the idea? All right, ignore the cleanup part. I don't care about cleanup at this point. All I care about is this part here. I'm gonna set a batch size of, let's say 16, and here the size I'm gonna set at 480. All right, let's not jump to 640 right there. Let's take it nice and slow. So, all right, validation, sanity check, looks good. Run the learner. Let's wait for it. All right, looks okay. Let's do fit one cycle. Are we gonna get memory issues? Are we gonna get memory issues? No, we're not gonna get memory issues. It's just gonna work fine. Now we're working with a size 480. So it's about double, more than double, the last size that we're working with. But what we wanna know is, are we seeing similar error rates or different error rates, right? That's what we wanna know. So let's wait till it runs. With the same sort of data set, we're seeing pretty crappy error rates. 30%, yeah, it's pretty crap. 28%, it's pretty horrible. All right, so now we're gonna unfreeze, run our learning rate finder, and plot it so that we can try that exercise again, but this time making sure to set a proper learning rate. So let's wait till that happens. So apparently it's going to take a bit of time. It's not going to happen instantly, and so we'll wait until that's done. But in the meantime, I wonder if there's a way to actually see all of the data that we've got uploaded. So if I wanted to see all the Gosling data, for instance, can't I view this? New? No, I don't want to create a new file. I want to see a preview of all of these images. Why is it so hard? Why can't I view all of these images? View. Okay, just showed me the first image. Oh, prevented it from opening more than 100 pop-up windows. That's good. That's good. I was wondering what was going on there. Alright, so it looks like these images are already set to 224. They've already been cropped. Oh, interesting. So even if you're training it on a larger... Wait, is it? So when we downloaded them, they were already cropped? Or they were smaller than the original size? So it's saying this one is 375 by 500. So just because you set the size bigger doesn't necessarily mean that it's going to be bigger, because I think what we're doing here is we're loading the thumbnails. We're not loading the full-sized image. Yeah, okay. All right, and that's what's happening. And so that's why it would make sense to do something like that. So let's run this with our learning rate of, 1e minus 4. So previously it was about 8% from what I recall seeing there. Let's see what happens. Wow, that's crap. All right, and so just because you increase the size doesn't necessarily mean that you're gonna fix everything up, because the source images that we have are, again, like their dimensions vary, but it's just looking like 500 by 374. 480 may be a good number, I think, just because these images seem to... This image, for instance, what's his size? It's about 500 by 281. Okay. Yeah, 480 would capture the longer side. Okay, yeah, it's not bad. Let's see what happens. 16, and it actually changed quite a bit, which leads me to think that maybe the learning rate is too high. Learning rate's too high, that's why it's jumping back and forth. It's not going in one direction, it's moving in a bunch of directions. So we need to make the learning rate even smaller. So I'm thinking 3E4. Let's see what that looks like. Remember, if it's jumping about, then you probably have a high learning rate. If it's not jumping about, you're probably all right. Yeah. So that's the sort of general rule of thumb. We want to hit about 8% error rate. That's what we had before. Whoa, still jumping about. What is going on here? And why is the validation loss so much higher than the training loss? That's surprising. It's quite surprising. I'd say it actually got worse when I made the image larger. Yeah, it ultimately hit 11%, but only after jumping a lot. So I'm going to make it even smaller. I'm going to put it at 1e minus 5. See what that looks like. Alrighty, we got some results and they look promising. Alright, this is much better. You know, we're at about 8%. Validation loss is still significantly higher than training loss. So, I don't know what that means. It probably means that it's trying to overfit our training data, and then that's why we have, too much validation loss. I don't know what that means and what we can do about that, but whatever. Let's save that. And at this point, we can run a test. So let's do that. You know what? Let's run the same image that we were having trouble with. All right. Let's run the exact same image we were having trouble with. So I'm gonna go to data Ryan's, and here we're gonna upload. Let's go ahead and upload those weird images that we were having problems with. So let's go to let's see, I'm gonna use the resized ones and see what sort of results we get. But again, like the resized ones are actually resized to the wrong size now. So let's just delete everything that starts with R. And what we're going to do instead is we're going to convert the size. So let's do G6. And G6-R, and we're going to call this, so this is resize. We're going to do 480 by 480. And we're going to call this G6-R.jpg. All right, and we're going to upload that image here, G6-R, and we're going to try that. So G6-R. So change this to G6-R. So this should be, this bad boy should be classified as Gosling, right? And so if it doesn't classify it as Gosling, then it is screwing up. Reynolds. Oh, come on. Come on, don't do this to me. It's even more confident that it's Reynolds now. That makes no sense. Is it because you've got another face here? Is that what's going on here? Like this other face is screwing up with his face? Is that, I don't know. I mean, if you Google his image, I think you'll get that it's Gosling. Why is it saying James Bond? Ryan Gosling, yeah. So Ryan Gosling, but our stupid script keeps saying Reynolds. Why does it think he's Reynolds, though? I don't know, man. Okay, you know what? That's all right. That's fine. This is totally fine. I have no issues with this. What we need to do is review all our data and just figure it out, right? We're just gonna figure it out and do this one step at a time. Do this all over again, and we're gonna get to the bottom of this. Again, if this is the last thing I do, we're gonna get to the bottom of this. All right, so that's part 2 of the same video. I'll catch you guys then.